Hello. Welcome to the presentation video of Operation Support System application. Today we will show you its functionality and advantages of using it. Right after the login, the user sees the initial page. Control Panel Menu tab is the most significant page of the system. This page displays the configured charts for the default dashboard. Dashboards show statistical values of parameters from devices in accordance with the sample and time period for a specific type of graph. The main entity of the system is a device. For working with devices, the user should open Device Management menu tab. While editing a device, we can configure its name, type, connection string, as well as an SSH key, which is required for establishing a secure connection without transmitting a password in an unencrypted form. We can also configure the frequency of checking ping status. Additionally, our system supports devices with MQTT communication protocol type. For such devices, a token parameter should be set and device should be prepared to use predefined communication topics. After a device is added, we can set up the logging configuration settings by clicking Logging button. Here we can see the paths of log files on the device to be analyzed, as well as the type of data in these logs. This can be either a JSON file or a free format file. Then we can flexibly configure its parsing using regexp. Additionally, a user can prompt a regexp help page to see the full list of regexps. After saving logging configuration settings, all parameters that are parsed from the log files are collected and saved to the system using Elasticsearch. The list of all saved parameters can be seen on Parameters menu tab. The next important entity of the service is a global parameter. Opening Global Parameter menu tab shows the entries' names of already configured global parameters. They are used to map metric beat, SSH, and MQTT data that is received by the system and later while setting up dashboard charts and alarms. In addition to the logging configuration, which is working with FileBeat service is installed on the device, the system can execute SSH CLI commands on the device with the help of the SSH Monitoring Template menu tab. To specify such a template, the execution command and regexp, parsing the result into global parameters should be set. Next to SSH Monitoring Template menu tab, there is a metric beat configuration templates. Going to this tab allows a user to work with the metric beat service that is installed on the device. While configuring such a type of templates, the user can choose from the specific list of predefined modules that work with well-known services, which can be run on the device, for example, Kafka, MySQL, and so on. In our case, we only monitor the system module and its submodules, such as CPU, load, memory, and network. When SSH is configured and metric beat monitoring templates are set up, it's time to assign them to the device. To link parameters on a device, a monitoring template must be selected and the checkbox must be enabled in the monitoring settings modal window of the device. Only after this is done, the data from the device starts to come into the system in order to assign metric beat parameters to the already created global parameters. In a similar way, a SSH monitoring template should be assigned to the device. A user should enable the checkbox and add to the list, then set a check periodicity parameter and list of global parameters. As it was mentioned before, after metric beat monitoring template is assigned to the device, the system start receiving the data collected by metric beat service. On metric beat monitoring parameters menu tab, the user can see all available metric beat parameters. Here assignment to the global parameters can be provided. After that, the current values of the collected parameters can be tracked using the monitoring module. Next menu tab is MQTT monitoring parameters. Here the user can see all available MQTT parameters that can be received by the system and assign global parameters to allow the system to collect the data. After metric beat and MQTT parameters are assigned, the user can go to Latest Values Monitoring menu tab to view the values, which have already been received by the system, and the resource SSH, metric beat or MQTT. After the user has set up the monitoring module and the data is being collected, the user can proceed with setting up charts on a new dashboard. To do it, the user should go to Dashboard's menu tab and create a new dashboard with providing its name. Then select a required dashboard, click on Edit Charts button. In the displayed window, click Add Charts button and fill in all required data such as name, chart type, aggregation. Choose the required device, the list of parameters we need to see on the chart, and so on. After saving and setting up the size and position on the dashboard, the user can see the chart and its update according to the chosen settings. Now let's move to the Alarm Templates menu tab. Here the user can see a list of already defined alarm templates existing in the system. Let's create a new alarm template. After clicking Add Alarm Template button, the user should enter all required fields, such as name, level, parameter to be monitored, trigger condition, and thresholds. Values should be specified with the device that should be tracked. It could be just one device or all devices that are in the system. A special template of the information message can be provided in the message field. Such placeholders as device, parameter name, current value, and check value can be used to parameterize the message that will be shown to the user. The main idea of an alarm is to track parameters of the devices and check it against abnormal values that could be received to have this historical data and inform a user about such situations in real time. For such purposes, there is a page for alarm notification subscription where the user can select a separate alarm of the entire level to subscribe on. Right after saving these settings, the system is ready to notify the user in case the alarm is raised. Now we can go to the Active Alarms page. We see the list of active alarms in the system now. These alarms are related to the alarm state machine, which is implemented in the system. When a parameter value is received by the system, it is checked against an alarm template. A new alarm record is created according to the condition of an alarm template if there was no existing active alarm before. In case such an alarm already exists, then a new alarm won't be created. And vice versa. If the correct value arrives, the alarm will be ceased automatically. A corresponding notification is displayed each time and a new entry is created in the alarm audit list. Let's go to the Alarm Audit menu tab. Here the user can see all historical data for all alarms and transitions between states of the alarm state machine. Now let's take a look at the role model and how it works. It starts from a role creation process on User Roles menu tab that later allows to assign a role to a user. On User Roles menu tab, already created roles are displayed. Depending on a role, each user can view only certain pages. Additionally, since our system supports access via REST API, there is a special tab to regulate it in a flexible way. Let's log into the system with a user account. We see that the content of the menu differs significantly according to the role model we have just viewed. As it was said before, the system supports access via REST API. There is Swagger documentation with detailed information on endpoints and entities that system is implementing. Thank you for attention. We hope you've enjoyed this video.